Okay, here are examples. So kind of, hopefully this might be a review. If not, just kind of pay attention on how to get to your reflection point, depending on your line of reflection. So right here, we have lowercase r, and then we have the subscript of x-axis. So that means that we're going to reflect our point over the x-axis. So I just highlighted that. And I'm going to go ahead and plot my point P, which is at 5, 4, which is my pre-image. So there's my point P. And because this is our line of that, since the x-axis is our line of symmetry, and I'm just going to put LOS, and reflection maintains distance, I can always get my reflection point by counting the distance. You can only count horizontal and vertical distance, though, on a graph from that line of symmetry. And I'll show you the difference on the next couple examples. So, for example, the distance from the line of symmetry from this point P to that line of symmetry is 4 units. Since distance is maintained, I can just go 4 units below this line of symmetry and plot the image P prime. So that is located at 5, -4. So kind of want you to notice something on this example, which helps you identify and use the rule. The rule is what you need to maintain and be able to memorize and apply, because we're really going to get into composite transformations, and then we're just using this as review of what you've done in the past in middle school or elementary school. So what I want you to recognize is that notice how our x coordinate here did not change, okay? But look at the y coordinate. Okay, our y coordinate, the value did change. So what happens when you're reflecting over the x-axis, okay, your x does not change, but, or however, the y is negated. If you look, my y was 4, and then it went to a -4, okay? So whenever we're negating the value of y, we're doing the opposite. We talked about negations at the very beginning of school when we were doing conditional. So x doesn't change, x stays. The y is negated. The y is the coordinate that changes. So it becomes the opposite of what the pre-image coordinate is. So what you need to know, and this is our point of emphasis, is the rule, the reflection rule over the x-axis. We need to know what the rule is for any point. Okay? The rule states that if I have any point and I reflect it over the x-axis, the x stays, the y changes. And to show the negation, that's what we do, the -y. Okay? So if I was doing the same thing over the y-axis, so on the next example, we're reflecting over the y-axis. So the y-axis here, I'm going to highlight that. That's our line of symmetry. Doing the same point. Our pre-image is the P. Remember, distance is maintained, so now I'm counting from this vertical line, and that's 5 units out, so I'm going to have to do the same thing to the other side. And there I get P prime. P prime would be now at a -5, 4. So look at the pattern here. When I'm reflecting over the y-axis, now, if you look, the x is negated, and the y does not change. So what you need to make sure you can do is the rule. Memorize the rule, because like I said, we're going to get into composite. That's more than one transformation at a time. So for any point, if I have an x and y, and I reflect over the y-axis, and that's indicated right here with the lowercase r and then the subscript of our line of symmetry, then the x is negated, so that becomes a -x, and the y stays the same. Okay, so make sure that you understand those types of reflections. Now we're going to get into a new one.